All right, we're just going to review finding the parts of a parabola in standard form and in graphing and vertex form. As far as factored form, I already made a video about how to find all the parts of a parabola in factored form for that 311 slash 312 that async work. So that video is still in your module. But what I would do right now is pause this video and get these things in your notes if they are not already in there. So we are going finding all the parts of a parabola in standard form. So standard form is obviously your ax squared plus bx plus c. Your easy part in this one that requires no math is your y-intercept. You just plug in 0 for x. Both of these guys just go away, and you're always going to be left with c every single time. Now, where the effort is involved is your x-intercepts. You are going to have to factor using your generic rectangle and diamond problem, and then you will have to use the zero product property. In order to get your line of symmetry or to find the x value of your vertex, you're going to have to take the average of your two x-intercepts or find the center, the middle of your x-intercepts. And then once you have that center, you have the x value of your vertex. So all you have to do is plug in the x value and solve for the y value of your vertex. So this is the problem we're going to be working on today. So the easy part is just your y-intercept. So let's just get that one out of the way. So if I plug in 0 for x, 0 squared is nothing, negative 4 times 0 is nothing. So we're always just left with our c value, which is negative 12. Now let's actually start doing some of the more difficult stuff. I'm just going to circle that so we know it's done. Okay, so now we actually want to factor this. So this is where we're using our generic rectangle and our diamond problem. Okay, so I have an x squared down here, my negative 12 over here, my a times c always goes on the top. So I have negative 12x squared on the top of my diamond. And I only have negative 4x's to split up. So now I need to ask myself what's going to multiply to give me negative 12x squared, but add to give me negative 4x. And after thinking about it a little bit, you should come up with negative 6x and positive 2x. Those go straight into my generic rectangle. And now I have to figure out what the product is. What is the length times width? So I know that it has to multiply to be x squared. These guys are obviously going to be x times x. What can I take out between negative 6x and negative 12? I can take out a negative 6, or negative 6 times x is negative 6x. The same thing over here. I can take a 2 out of negative 12 and 2x, or x times 2 is 2x. So therefore, what I have now is I'm going to just plug in 0 because I have to use the zero product property now. But I know my two factors of this are x minus 6 and x plus 2. But remember, these are not your x-intercepts yet because they're still in those parentheses. So now I have to use that zero product property. And I do want to see this step on your test. That just means I'm setting each part equal to 0, because if one of them equals 0, then they both equal 0. And remember, more often than not, those parabolas are crossing your x-intercept, your x-axis at two different points. So I'm going to add 6 to both sides, subtract 2 to both sides over here. So then x equals positive 6 and negative 2. However, I do not want to circle these yet, because if I'm asking you for your x-intercepts and you give me x equals 6 and x equals negative 2, I will be marking them wrong. So remember, if you want x-intercepts, you got 6 when you plugged in 0 for y, and you got negative 2 when you plugged in 0 for y. These are my x-intercepts. Okay, now for your line of symmetry, actually, I'm just going to label these x-intercepts just so we remember. All right, so for your line of symmetry, okay, remember we are just trying to find the exact center. Where is the point exactly in the middle of my x-intercepts, because that's where my vertex is going to be. So I'm just going to add these guys up. So I have positive 6 plus negative 2, and I want to find the middle, so I'm just going to divide that by 2. 6 plus negative 2 or 6 minus 2 is just 4. 4 divided by 2 is 2. So my line of symmetry, remember, it's a vertical line. It always has an x equal equation because every single point on that line is going to be x equals 2. That's my line of symmetry. But again, that is the x value of my vertex 2. So when I go and plug in, or when I go to solve for my vertex, I'm just going to plug that in. So y is going to equal 2 squared minus 4 times 2, and then minus 12. And again, you can't see, I'm just plugging it into our original equation over here. I know the x value is 2, so I'm just plugging in 2 for both x's. And then we just have to solve for y. So I know that 2 squared is 4, negative 4 times 2 is negative 8, and then minus 12. 4 minus 8 is negative 4. Negative 4 minus 12 is a negative 16. So what is my vertex? I plugged into for x. I got out negative 16 for y. And that is it. Okay, so that's how you solve for all of your parts of your parabola in standard form. So make sure all those get down in your notes, and then you can do it on your class kick. Okay, let's go on to the next one. Okay, finding parts of a parabola in graphing or vertex form. Remember, those two mean the same exact thing. So the easy parts of this is your line of symmetry and your vertex, hence why it's called vertex form. And again, pause this, make sure you have this stuff written down in your notes just so you can refer back to it. Now, when I do my line of symmetry, I write it x equals the opposite of h, just because I like to remind myself that it's opposite of whatever's in here. Technically, it's supposed to just be h, but I like writing it down the opposite of h, so I remember to change whatever number is inside here. So that's always going to be your x value. Remember, whatever's inside the parentheses with your x, it's always doing the opposite of that. Your vertex is always going to be whatever the opposite number of what's inside your parentheses is. That's your x value. And then your y value is always just going to be k. K has no reason to change. That's just whatever k is, that's the y value of your vertex. Now, where the effort's involved is finding your x and y intercepts. So your y-intercept's a little bit nicer because we're plugging in 0 for x, and then we're just solving for y. In this case, everything's on one side. We're just using PEMDAS. However, when we're solving for our x-intercepts, we have to plug in 0 for y and solve for x. Remember, we always want to try to look for those two solutions. And then for this one, since we're moving everything away from the x, this is when we want to use reverse PEMDAS. We want to go backwards. Okay. So this is the problem that we're going to be working on. And let's just start with easy stuff. So if I am starting with my line of symmetry, I'm just going to abbreviate over there. I know it's the opposite of whatever number's inside there with the x. So x is going to equal, in this case, negative 2. Okay? And that's, again, easy part. That part's done. All right, my vertex. My vertex is the opposite of h, and then whatever k is. So my vertex is going to be negative 2. Again, those always have to match with my line of symmetry. And then my k is just negative 27. And boom, just like that, done. So there's always easy parts to these guys. Now let's do the harder parts. So let's solve for our y-intercept first. It's a little bit easier. So my y-intercept, I always solve for y with my y-intercept, and I make the other variable, in this case x, 0. And then I just have to use PEMDAS. I'm just going to write PEMDAS up here. Okay, so that means I'm going to start with my parentheses. And I'm going to have 0 plus 2 is just 2. Then I got to do my exponent. So that means I am going to square the 2. So I'm going to have 3 times 4 minus 27. Then I'm going to do my multiplication. 3 times 4 is 12. And then I can do my addition or subtraction. So 12 minus 27 is just going to be negative 15. Okay, and again, that's not my y-intercept until I make an ordered pair. So when I plugged in 0 for x, I got out negative 15 for y. And then that part's done. Okay, last part, x-intercept. Okay, so now I'm plugging in 0 for y, and I'm solving for x. Okay, this is where we want to do PEMDAS in reverse. We want to get everything away from that x value over there. So now I'm going to start with the addition and subtraction. Now remember, there's addition inside the parentheses and there's subtraction outside the parentheses. I cannot take that 2 out of the parentheses until I take care of the square, and the 3, that one's kind of locked in there. So when I say undo the addition and subtraction first, I'm always talking about this k value because it's kind of removed from everybody else. So that's going to be the first one that leaves. go into the other side of my equation. So now I have 27 equals 3 times x plus 2 squared. Now the addition and subtraction is done, so I'm going to move on to the multiplication and division. The 3 is getting multiplied to the x, so that's got to be the next thing that moves. So I'm going to divide both sides by 3. Those guys canceled out. These 3's are going to cancel out. 27 divided by 3 is 9. So now I have 9 equals x plus 2 squared. So now I am on to the exponent when I'm doing PEMDAS backwards. How do I undo a square? We guys should know by now it is taking the square root. Okay, so the square root of 9 is 3, but remember, I'm really going for 2 x-intercepts over here. So whenever I'm taking the square root, I can square 3 to get 9, but I can also square negative 3 to get 9. So I'm going to write this as plus or minus 3. And then my square root and my square just canceled out. What do I multiply by itself to get x plus 2 squared? I multiplied x plus 2 by itself. All right, I'm going to move this guy over just so I can show a little bit of work over here. So now, since I have plus or minus 3 over here, what I really have is 2 different equations. So what I have over here is x plus 2 can equal a positive 3, and I have x plus 2 can equal a negative 3. So I have to set those equations down there, and then I just have to solve. So all of these, I'm just subtracting 2 from. So this one, x is going to equal 3 minus 2 is just 1. Whoops, I don't want to circle that yet. And then negative 3 minus 2 is going to be negative 5. Okay, and I almost circled them, but again, I don't have those x-intercepts, so I make them an ordered pair. So I have x is 1 when y is 0, and x is negative 5 when y is 0. And how can you double check these just to make sure you are right, that you didn't make a mistake? Well, if I add these two values together, negative 5 plus 1 is negative 4 divided by 2, which is negative 2, and that is my line of symmetry. So I do know that I did these right. And that's how you find all your parts of a parabola in vertex form. Okay, and on the very end of your class kit is just turning the other forms into standard form. So I have a vertex form and a factored form over here. Again, watch the other video for the factored form to find all the parts of your parabolas. Okay, over here, when we are putting these into standard form, we're still kind of following like order of operations over here, except for when it says parentheses, we can't add anything or subtract in this case because we don't know what x is yet. So the first thing that we want to do is use our generic rectangle, because when I take care of this exponent, I know that if I'm doing x minus 3 squared, I have x minus 3 times another x minus 3. So I'm going to use my generic rectangle. X times x is x squared. Negative 3 times x is negative 3x. I'm going to have another one up here. And then negative 3 times negative 3 is always a positive. Whenever you're squaring something, that constant term is always going to be a positive. And whenever you're squaring a binomial, these two middle terms, when you go to combine like terms, always going to match. So now that x minus 3 squared is turning into x squared. Combine like terms to get negative 6x and then plus 9. Okay, the rest of it is coming down around it. So I still have to multiply this stuff by 2 and subtract 10 at the end. Okay, so now I did my exponents. Now I'm going to do my multiplication, which just means distribute this 2 to everything. 2 times x squared is 2x squared. 2 times negative 6x is negative 12x. 2 times 9 is 18. And then we still have that minus 10 at the very end. And then all we have to do is combine like terms. I'm going to bring the y back down into this. Y equals 2x squared minus 12x. And then 18 minus 10 is just 8. And there you have it. That is standard form, ABC. Okay. When you go to turn factored form into standard form, you have 2 options. You still have to do both rules, but it doesn't really matter which way you do it. The first thing that you can do is distribute this negative 3 to only one of the parentheses, and then you can use a generic rectangle. Or you can do the generic rectangle between the x plus 1 and the x minus 4 first, and then distribute the 3 out, just kind of like what we did up here. I'm going to do it the other way. I'm going to distribute this -3 first, just make it a little bit easier. Remember, we're only distributing it to that first one. It doesn't need to go to both. So we have -3x minus 3, and then we're multiplying that by by x minus 4. Then I'm going to use my generic rectangle. And again, we still have a product, so we have the outside of our generic rectangle. So now we're doing -3x and -3x minus 4. So -3x times x is going to be -3x squared. -3 times x is -3x. -3x times -4, negative times a negative is positive, so I'm going to have 12x. And -3 times -4 is positive 12. So then what's going to be my final answer? I just have to combine like terms. Y equals -3x squared. Combine like terms, 12x minus 3x is 9x, and then plus 12. And that's it. All right, good luck. Remember your test is on Wednesday or Thursday, and we'll see you then.